This section is about energy and doing work. So you're trying to lift something heavy, your dog, to a great height. You do it first using a seesaw or lever, and your dog ascends to 3 times the height that you descend. Then you lift your dog higher still in a bucket attached to a pulley system, but it takes you pulling through twice as much rope as the distance he goes up. What's the reason for this apparent difference in effort? First, the lever. You're heavier than your dog and you use your weight as the force at the other end of the lever. The lever turns about a pivot, so to push it down we need your moment to be slightly bigger than your dog's at the other end of the lever. Remember that the moment about a point equals the force times the perpendicular distance from the line of action of the force to that point. What this means is that if your weight is 3 times bigger than your dog's, or more, he can be 3 times further from the pivot than you, and when you go down, he goes up by 3 times as much. Second, the pulley system. This time you're using the strength in your arms, and possibly some but not all of your weight, to lift your dog by pulling on a rope. Because the weight of your dog is distributed over a doubled up rope, the tension that you have to put into the rope to lift him up is only half his weight. However, because the rope is doubled around the pulley, you need to pull through twice the distance of the rope than the distance he goes up. What have we learned? If you use more force, you need to use less distance, or if you use less force, you need to do it over a bigger distance. However, to increase your dog's height over a given distance, the effort needed is the same. This effort is known as work done and is given by the force times the distance moved in the direction of the force. Work is a form of energy and is measured in joules, or kilogram meter squared per second squared, in SI base units. Machines, such as levers or pulleys, allow us to, for example, get more force out than we put in, e.g. lift something heavier than ourselves. However, the work done, that is the energy in, is the same as the energy out. In the case of lifting your dog to a great height, we say that you do work against gravity. At the end of this process, your dog has gained the energy that you put in. We say that he has gravitational potential energy, and this energy is given as his weight times the height he is above his starting point. Finally, we've said that energy is conserved, that is, energy in equals energy out. This is true. However, not all the energy input is transformed into raising your dog's gravitational potential. If it was, we'd say that your machine was 100% efficient. In fact, some of the work you do gets transformed into different output energy. Can you think of the places where this energy might be lost? We can't get more energy out of a machine than we put in.